Educational Codeforces round 93 or 94. Oh, 93. It's impossible if one side is greater than sum of two. So basically you want the first two and the last, and we compare them. If a of 0 plus a of 1 is greater than a of n minus 1, then the answer is negative. It is impossible. Otherwise, you output 1, 2, n minus 1. Actually, it's just n. They will only take ones. Alice goes first, right? Yeah, it makes sense that they only take ones. You can do some proof by contradiction. So I need the length of the ones. After I sort them, then I take every other one. In order to find the runs, C is equal to 1, and we add L. Otherwise, L is set to 0, and we add L into the vector. Oh shoot. Same variable names. One stands for sum, the other stands for the string. This seems to work. So all of them are digits. This is some basic map. I think this is a pretty standard prefix sums. Pretty standard problem using prefix sums. Oh, you don't even need a map, but it's probably easier with a map anyways. We add the digit to S. We add the prefix sum. We added minus I plus 1. Then we add the value, find the count of the previous prefix sums. 3, 6, 1. So the way it works is that if we decrease all the numbers by exactly 1, then it's basically counting the number of subarrays which are equal to 0. Accepted, okay. I think this is DP. I'm not sure. So let's say you had, let's do some casework. If you have the biggest R, then I want to maximize, okay, yeah. So if they're sorted by some order, if this is the max, then by some inequality, it would be better to pair them like this. So if I wanted to pair my max R with something, okay, what about this case? Let's prove that you must pair with the max something. So if it looks like this, then how can you make this better? Do RG and then GB. This only works if R is greater than B. Okay, but one of them must be true, so yeah, I think I just proved that you'll take the max 2 at some point, which makes the DP solution work. It won't overflow, right? Wait, probably not, but 300 times 2,000 at 2,000. Yeah, that won't overflow. Actually, I shouldn't even have checked, but whatever. RGB. And the answer is just dp of r GB. And we need to do input. After that, we just process the DP. We loop through all three possible cases. If I and j, then jk dpi minus 1 j minus 1 k plus r I minus 1 multiplied by g of j minus 1 if I and k just copy this. G of j minus 1 multiplied by b of k minus 1. Okay, I'm not using my macros today because I forgot to reset my template from the last div1 round. 20, 99. Oh shoot. Oh yeah, I need to sort everything. That's been pretty embarrassing. Luckily they had this in the sample tests. $372, that's correct. So let's submit. It took a bit of time to write. Accept it, okay. What does it mean D can be negative? Oh, okay. So it tells you if it learns or forgets. How do you want to structure? Lightning spell allows you to add something else. I should have a spell of 0 at the start. can basically get the top k, right? So it's maintaining the top whatever sum. K will be the number of lightning spells. S2 will be the top, yeah. So it is T1 plus T2 multiplied by 2. Okay, I'll just do this. This is lightning, and then this is fire. So after a lightning spell, what happens? Then we increase K by 1. Wait, actually it depends. D is greater than 0, we increase K by 1. Otherwise, we decrease K by 1. Subtract K, which means we do the opposite. Now we just need to handle D, okay. How do I deal with this? If D is less, then if it's in S1, we erase it from S1. Otherwise, we erase it from S2. Then I'll call this move up. Similarly, I'll have a move down, which moves something from the top set to the bottom set. If we raise from S2, then we need to move up. S2 is not empty and the gain of S2 is less than D. That means we're adding to S2. And we move down. Otherwise we just add to S1. Okay, interesting bug. Starts at 5 at first. Wait, you can take anything but yourself. So there's exactly one lightning spell which cannot be taken. Okay, I'm going to keep a set of all lightning spells. And I'll temporarily erase that lightning spell, if necessary. If you can find it, then first let's erase it. Let's move something up. Then after that, let's move something, move it back down. And then, yeah. Is it still 10? Well, that's because I forgot to erase. I forgot to subtract. Zero 25. Have to add it back to T1. Okay, now everything seems to work. There doesn't seem to be overflow, which is great. Let's check how I'm doing after 26 minutes in the contest. Hopefully this passes. This is not a nice problem. F. So let's check F and G. Oh, people are solving F. More F's than E. Accepted, okay. Which puts me in second, tied with third. It might be an n log n algorithm. Yes, do a greedy algorithm. You start from the left. You try to go. Check the next X letters and see if they can all be the same. If they can, you jump to the next X. If you can't, then you jump to after the last one inside of that block. So I need previous 1 or previous 0. Recover. We have previous. Just make this of size n plus 1. It'll probably be easier. Previous I of s of I and 1. I should be updating I plus 1. Is equal to I. S is equal to 0. Oh, s plus x is also not equal to n. We check with something, and the answer will be stored in C. Probably check with prefix sums. Okay, so that'll be, prefix sums will be stored in A. Plus 1 s of I and 1. So check from s to s plus x. if a of s of x, 0 minus a of s of 0 is equal to 0, that means we can put 1 in there. We do the same check for 1. Wait, but otherwise, what do you go to? You go to something. What's the next character we check? Previous s plus x. If 1 is greater than equal to s plus x. 1 is, if it's greater than, oh yeah, there's also the case if it's a question mark. In that case we continue. Don't update any of those things. That means the last one is B. Previous plus 1, something like this. I'll just test it. Okay, this works. This also works. And this also works, so I'll submit and hope that it actually works. Test 3, test 7, test 18. Fourth, well, I thought it was going to like TLE because I didn't really prove my solution. But I've just seen a similar problem before. So that's why I think that. Okay, accepted. So second place again. Y equal to 5, okay. Bunch of vertical segments. Is it divisor of L? Even integers. Okay, that makes sense. Maximum possible length. So basically I divide the given thing by 2 and then I subtract by y and make sure that's still positive. After that I get a number. Wait, no. So this reduces to, I want to find a of I minus a of j plus y. And this should be a divisor of L of I divided by 2. Just L. And I should take care of the constraints. Is this FFT? When you're thinking about pairwise sums or differences, then there's a very high chance that it's FFT. Use FFT to find all the segment lanes. After I find all the segment lanes, to find the segment lanes, I can do this n log n propagation. Okay, I think I got it. But I need to pull up my FFT template. So what's the exact polynomial I'm creating? Let's go to add Codegram contest and copy the FFT thing that I used. I create something and it's reverse. Okay, yeah, this makes sense. Int and xy. This is a pretty bad problem, but whatever. Contains n plus 1 integers. C1 beta x. C1 and then x minus b dot y. Multiply them together. And I should get something of length 2 times x plus 1. I create the real C. Ci minus x is equal to just choose the current thing. And I propagate to the multiples. Oh, I have to add y. This is funny. Actually, I need to do this up till 10 to the 6. So I add y and then C of j is the maximum of C of j and C of I. And then finally the queries. And there is C of L divided by 2 multiplied by 2. Supposed to output that, them separated by spaces. My FFT is slow. Something weird happened. Okay, I need to add y first. Yeah, that's the first part. Okay, now this should be good. I basically just reformatted the answer. Wrong answer on test 1. Got 18 somehow. What? Do I need to mend set? Okay, this time it should work. Running on test 8. Test 11. Okay, I expect him to solve it in like 10 minutes as well, because this is a pretty standard problem. So it turns out that E was the hardest problem of this round. Actually, maybe it's... I would say D might be harder. D or E are the hardest, and then it's F, and then it's G, and then it's C, B, A. That's how I would rate the difficulty of this round. Yeah, as expected, he solves... Nick solves it in 6 minutes because it's a template problem. But still got second, which is... I don't feel proud about getting second for this type of round, but I guess it's still good. I don't think I'll fail any system tests, so yeah, I should remain second for the rest of the round. Yeah, I have pretty good penalty time as well, so I don't think I'll go down. But overall, I don't like this round because of problem E. I don't know if there's a good implementation for problem E, but my implementation was not that pretty, and I was lucky that it passed the first time. And then for G, it's just way too standard, so that's why I don't like G. But it's an educational round, so I guess you can't really complain about the problems being standard. Anyways, I'll see you in a next contest. Goodbye.